We'd like to just welcome everybody to attending this. We appreciate you taking some time out of your day to chime in here and hear what we have to say about UAS. The presentation today will be on data-driven unmanned aircraft systems, products and services for GIS and Aerial Survey. We're going to focus a lot on what our company, Electronic Data Solutions, has been working on over the past 1.5 to 2 years, what's been coming, and then finally what we're reaching here. We won't get real technical on this presentation today. This will be more of an overview of what's going on in the industry, what's going on with our company, what UAS services and products are available to you, and then I will cover some basics, however, for those who this may be newer to than others. If you have any, just a few housekeeping things, I guess, you're welcome to ask a question in the chat or below. As we go along, we'll try to save those for the end to answer, and we'll have a Q&A session. We'll have a few polls, so keep an eye out for those where you can kind of respond and give us some feedback on what your use case is, and then we will just press forward. If you have any trouble hearing or anything like that, try to alert me somehow. Everybody's on mute, so there shouldn't be anybody heard but me at the time, but we'll go ahead and go forward. Okay. By way of introduction for me, so I'm Chase Fly. With that name, I was destined to be in aviation of some sort at some point. But I'm at Electronic Data Solutions here. I'm currently kind of working as the UAS team coordinator. I do a lot of our traditional business as well, distribution of hardware and software products from Trimble, navigation, from Esri, from Juniper Systems, and others. I coordinate our rental equipment, but I've been kind of leading this UAS effort here and getting everybody involved and making the right connections. So I'll be the one to ask any questions too. I'll be the presenter, and then I'll also be available to anybody afterwards. We do have a number of sales reps throughout the Pacific Northwest in particular, so many of you have probably worked with them. Jim Lum in Portland covers Western Washington and Oregon. Jackson Bigley in Missoula covers Montana, Northern Idaho, and Wyoming. Ryan Pearson covers Eastern Idaho. I'm based out of our home office in Jerome, and I cover Southern Idaho, Eastern Oregon, and then Sean Minton is in Sacramento and covers California. And then any of us here at the home office, myself or Michael Clancy is another point of contact who can assist. A little bit about Elecdata. If you're not familiar with our company, we've got about 30 years experience in field data collection. So we've been really built upon that, particularly in the natural resources fields, water quality, water instrumentation, GIS, geospatial industry. We are very focused on geospatial technologies. We are an Esri Gold partner, have been for many years. We are familiar with the ArcGIS platform and Esri technology and integrating field data into those systems. We're a Trimble distribution partner as well for their mapping and GIS portfolio, as well as UAS now, and we have been serving that capacity for many years. So we have a lot of experience with geospatial products and use cases, and particularly stuff in the field and how to get it back into an office system. So besides being a distributor of out-of-the-box hardware and software, we've also been a long-time service provider and systems integrator, anything from developing custom software applications to database integrations, professional services, trainings, support, technical support, all kinds of things. We are very well equipped and prepared to handle service type opportunities. We're based here in Jerome, Idaho, about 25 employees. About half of us work here out of the home office and the other half work remotely. The big news that we're announcing today, getting right into this, is that we received our Section 333 exemption from the Federal Aviation Administration. We received that back on July 15th, so it's been a couple months already. But this is exciting stuff. If anybody's been following the UAS industry, that exemption essentially gives our company authorization to operate unmanned aircraft systems commercially and legally. So we can fly. It is specific to the Trimble UX5 at this point, although we anticipate filing an amendment to add other aircraft for different applications. But right now we can fly the UX5 for aerial surveys, remote sensing, photogrammetry, that sort of thing that we'll talk about. This has been a long time coming. We've been working on this project for well over a year, closer to 2 years, and have been going about it the conservative and legal route. We didn't want to jump into this and expose ourselves or our customers to undue liability or issues, and we wanted to make sure we got into this industry right. And we want to focus on our customers, geospatial and the geospatial industry. Many of you have, probably most of you have done some sort of business with us in the past, and hopefully this is one technology that we can add to the hat, and that you can rely on us for support and training and direction and even services if needed. So we're officially kicking that off, and this webinar today is part of that announcement and equipping ourselves and educating our clientele on what we're doing. So we're excited about it. We'll be offering UAS services, actually flight operations and data processing and things like that, as well as offering Trimble UAS sales. So right now we're distributing the Trimble UAS products, of which there are a few, and we'll talk about that a bit more in detail later. For those that may not be quite as familiar, just a quick introduction to UAS. That stands for Unmanned Aircraft Systems, and it's more than just a drone. So many of us just think of this little piece here, the drone. But there's a lot more that goes into it. There's the ground control station, which usually consists of a controller, excuse me, like a field computer or tablet and some field software. And then a big piece is the data processing software. Trimble Business Center is one of those softwares with the photogrammetry module, but there are many out there. That's often an underestimated piece, as it can be a significant cost, and it's of significant importance, because at the end of the day, what we're really after is good geospatial data, and the rest of it's kind of just a fun and exciting tool to use to get that. So when we say UAS, we're sort of talking about this entire solution, the entire system. Photogrammetry and aerial survey are not new technologies. These are proven methods of geospatial data collection. Photogrammetry has been around for decades, and aerial surveys have as well. From the air, you get a different perspective on the Earth's surface, so you can collect all kinds of information from assets to buildings to other structures, landscapes, vegetation. We use remote sensing methods to collect information. Photogrammetry, this is just a screenshot from a software to kind of show you what the method is behind it if you're not familiar. Every white dot on that little map you see is a photo station. That's where a photo was taken from the air. The white line zigzagging throughout is the flight path of the Trimble UX5 on a recent flight. And the gray polygon below is the mission area. That's the target. That's the area we were trying to capture. Those blue points are ground control points. They were actual physical aerial targets we put on the ground and surveyed in. And then those orange rays or lines are rays between images and the ground control points. Those are often referred to as tie points. So photogrammetry essentially takes many, many still images, finds common features in different images, and stitches those images together into one large aerial image by way of finding common images in others. So all these images overlap to some degree. This is about an 80% overlap, which allows us to find many common features from many different photos. By doing that, we can ortho-rectify the imagery, stitch it all together, and create a nice geo-referenced aerial image like what you see here. So this would just be a sample of one of the outputs. A full color aerial image, high resolution, and then the unique thing about it with photogrammetry versus just taking a picture, a single picture from an airplane with any old camera, would be that this has metrics in it. We can measure distances, volumes, coordinates of individual positions or features inside of that image. So photogrammetry is the kind of method here, and that's nothing new. Neither is aerial survey. But what is new is the application of it and the miniaturization of equipment, so that we can actually use that on a smaller and higher resolution scale. Just a brief overview of geospatial applications for UAS. This is probably pretty obvious to most of you. In GIS and mapping, this data can be used for background maps, modeling and analysis, extracting features from the imagery, whether that be mapping assets or entering vegetation or pipelines or any sort of features that you might be interested in that show up in that imagery. That's a common use for it in GIS. Route planning, remote sensing, it's using we can use different types of sensors to collect different types of raster data that we can then derive information from, that we can make decisions off of, and that's the basic use case for GIS. Engineering and survey obviously is a big application for it. Volumetrics, calculating volumes of pits or stockpiles. Topographic surveys of a landscape, which can aid in design of infrastructure or other features. Feature extraction as well, identifying as-built, structures, buildings, natural features, or whatever it may be. You know, in a mining situation, you might want to calculate the volume of that pit, what's been extracted, and monitor that over time. Very handy tool for site surveys and inspections and many other things. The industries are numerous. This is just a few. I'm sure you could think of many others. Telecommunications, obviously ag, precision ag is a big one. Fish and wildlife, environmental assessments, noxious weed detection and different vegetation type of management situations, cultural resources, archaeology. There are many opportunities to use UAS for aerial survey. Just a little bit of background on manned flights and satellites. So the traditional way of collecting aerial imagery would be one of these methods. They're best suited for large-scale projects. That's kind of where the economies of scale come into play. They often provide lower resolution than what we can get flying lower with good sensors from the UAS, but even that resolution has been rapidly increasing from far distances. It can be very expensive to purchase satellite data or to acquire high-resolution aerial photography from a manned aircraft. This is also weather-dependent. Clouds obstruct the view of the surface, so whether that be from a satellite or an airplane, if it's a cloudy day or poor weather, the flight might get delayed. The data capture might get delayed. That can result in a time lag for data delivery. Also, the way the data is processed may be different, and there are some limitations to manned flights and satellites. And one of the big ones, those big ones being that cost factor. So why UAS? Perhaps the greatest argument is the cost. It's a much lower cost solution to acquire similar, or in many cases even better, more accurate, higher precision data. There are many new applications for it that we may not have ever considered using an airplane for, like bridge inspections or smokestack inspections or low-level pipeline inspections or close, near-sighted type of asset management. So lots of new applications that weren't open to us before, or that manned aircraft just are not capable of doing. So it's not always replacing what manned aircraft do, it's actually enhancing what we've typically done with aircraft and remote sensing. There have been a lot of advancements in technology that have enabled this. Miniaturization of sensors, great advancements in algorithms plugged into GNSS receivers and IMU units. There are the lightweight materials that are available now to do this. Battery enhancements have allowed electric motors to carry heavier payloads for longer periods of time. There's lots of advancements in tech that have made this possible. UAS can fly in bad weather. Clouds aren't usually a big deal unless they're on the ground. Where we're flying between, a couple hundred and 400 feet above the ground anyway, usually, sometimes less. Clouds can actually be a benefit on an overcast day if it evens out the lighting for your surface, for your photos. Light rain and clouds and even wind are often not a problem. It's a quicker deployment. You can get one of these things up in the air very fast. You can get higher resolution imagery down to a centimeter. Very simplified workflows with all the apps and controllers and manufacturers out there working hard on this. There's a lot of good opportunities for simple workflows. It's a quicker data turnaround. You have more control. You get your data off the sensor, and you can have that processed often within a day. Sometimes it might take a week, depending on file sizes and what you're doing, but there's a quicker data turnaround, and you have more control and fewer delays on account of weather or air traffic control or things like that. And the data you get out of it is GIS or CAD ready. We get a lot of data that's ready to be directly input into those systems for analysis. So some challenges for UAS that are mentionable, though, are it's not always best for large-scale projects. It may not be economical if you have to do 100 flights with a small UAS versus a single flight with a manned aircraft. Urban areas can be a challenge for privacy concerns as well as safety concerns. May not even be permitted by the FAA. In often cases, likely not to be permitted if you're wanting to fly over a super urban area. Or near airports can be problematic or not allowed. Over crowds of people, stadiums, things like that. You've probably heard on the news these instances happening where people are doing things that just are not smart and causing trouble. If you've got large sensors or specialized sensors you want to use, a UAS might not be the right tool. Then anything that's beyond visual line of sight, a lot of these linear projects we think of that are pipeline surveys or electrical utility surveys where you might want to fly a drone 10 miles, 50 miles, 100 miles away from a single location. Right now it's just not going to be allowed by the FAA. Everything's got to be within visual line of sight. That will change over the years to come as technology improves and things change, but right now that is a limitation of UAS. So, when you come to us and ask about a project, there may be cases when we suggest this isn't the right tool for you. But there will be many where it is. And many opportunities to use it where you would have never considered hiring out a flight before just because of the cost or the access, but now we can do things that we couldn't do before. Let's do a quick poll. Just want to get some feedback on which applications are you most likely to use UAS for. If you select all that apply, I'll give you a few seconds here. I'm curious to see what people have to say. I'll give about 15 more seconds here. Okay. All right, looks like about, just so you kind of know what those results were, about 60% said environmental, and about 60% he also said engineering applications, kind of survey, volumetrics, design, 20% ag, 37 natural resources, and 27% of you have different other applications. So thanks for your feedback there. Always kind of interesting to see what the crowd is. That's kind of about what I expected, given most of you have worked with our company before, and we're pretty familiar with what a lot of you are doing. Okay, a little bit about the data output. So standard data outputs from these systems are aerial survey UAS systems, excuse me, are these three outputs. These are usually the kind of out of the box, off the shelf software outputs that are then taken and manipulated or analyzed elsewhere. Georeferenced Earth mosaic images, digital surface models, and point clouds. On the surface models, do note that when we're using UAS and we're using photogrammetry, that is a true surface model. That is whatever is seen in the surface of that image, which may include buildings, rooftops, cars, people's heads, the crown of trees, the tops of bushes. You're not seeing a bare earth model. To get that bare earth, there are some third-party softwares and algorithms out there you can use to kind of extrapolate where bare earth is versus what you're actually seeing. But the digital surface model you get by default out of these systems is going to be the tops of vegetation and things like that. Just be aware of that. That's one of the limitations. I mean, sometimes that's the target of it anyway, so it's not a limitation, it's a benefit. But there are times when you want, maybe what you were actually after is a digital terrain model. And just know that with these methods, that's going to take some additional analysis. You know, as LiDAR sensors become more and more integrated into UAS and we have more active sensing techniques, we might be able to enhance that and actually get some really solid terrain models out of this technology. But right now, for the most part, the off-the-shelf and the commonly used systems are producing surface models. Same with the point clouds. That point cloud is going to be a high-density point cloud, an LAS file, much like a LiDAR file would be, except you're going to be looking at what a single return LiDAR file might look like of the surface, the tops of trees, the tops of bushes and buildings and things like that. You're essentially taking each pixel in that photo and assigning some points to it and associating those XYZ values with that pixel value. So those are the standard outputs. So let's take a look at a few. So here's just a high-resolution aerial image of a site taken from a UX5 and a camera sensor on board. Full color. You've got some relief there, some variation in terrain, vegetation, roadways, buildings, many types of assets that many of you are probably interested in collecting yourself at some point. That orthomosaic that has been stitched together can be then modeled into a digital surface model. This is what that would look like, and you can kind of see what I'm talking about with the visible building structures, vegetation, things like that. You see a clear bare earth where there's just grass or dirt or roadway, but many times you're looking at the actual surface. But you do get a nice rendering of a digital surface model that is very high resolution and very useful. Here's another high resolution image of an industrial site with some different features on it. When you take that and create a surface model, a 3D surface model like this, you can that also gives you the information you need to generate a layer like this. I don't think this is the same site, but gives you the same idea. Topographic maps, you can overlay, you can bring this into your GIS or CAD system and do design off of it. There are many uses for this data, and it can be interpreted or analyzed much further than just those standard outputs you get from the majority of the software programs, processing software programs out there. Another rendering of a surface model on the top, and then down below you see a colorized point cloud. Not super high res on the presentation here, but but that would be one of the outputs is an actual 3D model, much like this one of a mine site. You've got a 3D model of an open pit mine that with a stereo monitor or some 3D software, you could visualize that entire thing in 3D. 3D printer, you might be printing that out and putting it on your desktop. I don't know, but you get a lot of information out of that. You can do all kinds of design work, calculations, especially in an open pit mine. You could calculate that volume now and do it again in 3 months and figure the difference to understand how much is actually being extracted. You know, collecting data from a UAS on a site like this, many industrial sites, mines, landfills, other areas where heavy equipment might be going on or you've got unstable terrain, is also a much safer way to do it. You're not sending a crew of surveyors down into the pit for a week to go topo the whole thing. That can be costly and dangerous. It also means you might have to shut down operations at your facility to actually conduct a survey, whereas with UAS, everything stays operable and you can fly it all in a day or half hour maybe. You know, just depends on the size and of the site and your objectives. But much quicker and safer process to collect data this way. And you're getting very high resolution information, I mean down to 1/10 of a foot or better in many cases. All right, let's look at another quick poll here. Which UAS data deliverables are you most interested in? For your application, are they just the standards? Select anything that applies there. Or are you interested in more of the derived products? Give you a minute here to punch those in. All right. Thank you. So I've got about, I'm going to close that poll. About 80% of you said you're interested in the imagery, just the RGB color imagery. About half of you are interested in something near infrared, half of you in point clouds, 70% in surface models. And then 2/3 of you are interested in derived products, so whether that be modeled, classified, or analyzed later. Sounds about right. Very good. All right, so what's happening in UAS? I want to, actually there's one other poll before we jump into that is related to this. Let's do that real quick. How do you intend to consume data collected from UAS aerial surveys? Are you a GIS shop, CAD shop, you're just after pretty pictures, or you want something else? Give about 15 more seconds here and we'll wrap this up. Okay, great, thank you. I've got about 75% of you are interested in the GIS. Using it in GIS, about 15% CAD users, and a handful of you just are interested in imagery, and then a handful of you have other uses for it. Good information. That doesn't surprise me too much since we've been a very GIS-centric company. Makes a lot of sense that our customers would be interested in that as well. All right, I'm going to go over a little bit of what's going on just in the UAS industry. This will be kind of an overview of rules and regulations and market and things like that. So, a little market research. Many of you have maybe heard this. The FAA back in 2011, they kind of really started looking at this, and the FAA estimates that about $89 billion will be invested in UAS worldwide over the next 10 years. That graph below you're looking at kind of covers the last 5 years and the coming 5 years, but needless to say, this is a big industry, and obviously this doesn't just apply to aerial survey. A lot of these are filmmakers and hobbyists and military use as well. So, but over half of that money is expected to be invested in or spent in the U.S. And it equates to several billion a year. This is no small market, and it's anticipated to grow. It may level out at some point in the next few years as costs come down. I think drones will be around for at least the rest of my lifetime, but I think we will see some costs continue to drop as they really start figuring out the sensors and things, and as they start addressing the safety concerns that the aviation regulators have. You hear a lot about it in the news and from the FAA. Just a few clips of press releases and things. Just yesterday, those 2 articles up there from UAS News were from, I pulled yesterday. There was another drone sighting in Northern California that halted some firefighting. We've heard that several times now this summer. I think the most notable was one of the first in Southern California, where they grounded all manned aircraft because there were a couple of rubberneckers flying their drones around and taking a look at photos and flying near aircraft thinking that's cool. There's a lot of ignorance, I think, out there, especially in the recreational community, where anybody can go buy a drone for anywhere from $20 to several $1,000s off of Amazon, and that turns you into professional. These things are so easy to fly now because of the sensors they've got in them. It's not like the old days of RC aircraft guys who spent more time on their paint jobs than they did on their controller and have beautiful aircraft that they hesitate to ever fly because they were so sensitive and hard to fly. It doesn't take much skill anymore. It can all be automated. You fly it with your iPhone, and a lot of people are out there doing things that they may not realize are unsafe or illegal. There was another just a couple days ago where someone was flying a drone, excuse me, in town in Pasadena at the city hall, and it went a little haywire and landed on a baby and hurt a baby, an 11-month-old kid sitting in a stroller. So the FAA, even when we're flying these things 20 feet, 100 feet off the ground, there are some real concerns. Privacy concerns is another big one. Whether or not I have the right to go fly over people's backyards and take pictures of them, even though I'm not standing on their property, I'm flying over it. There's a lot of legal and ethical issues associated with the commercial industry as well as recreational, and we just need to be aware of that. We need to be responsible users of the technology, especially as professionals. We don't want to go out and just do this willy-nilly, just buy something off of Amazon and start flying it, thinking that we're wiser than the next guy. The FAA has proposed a rule, essentially legislation for small unmanned aircraft systems that is under review, but it probably will be for at least another year or two before anything's official. That should make it easier to operate these things commercially than what the current rules are, but which we'll get into. But that's still a ways out, so we've got to work within the system that exists now for the time being. The FAA recently released stated model aircraft guidance. They're trying to crack down on a lot of those issues they're running into with people flying drones near other aircraft. A recent report came out that pilots have reported more than double the sightings of drones within close proximity to manned aircraft than they had seen this time last year. So it's a very real safety concern that is the biggest issue that the FAA is facing is how do we safely manage all these low-flying aircraft with all these manned aircraft. You know, how do we deal with that guy who's trying to take video of a search and rescue helicopter from a quadcopter? You know, these are things that can seriously injure or kill people. And while there haven't been too many or any of those serious incidents that I've heard of yet, it could very well happen, and they want to do their best to mitigate it. So it's our responsibility to know the regulations and to know what we need to do to work within them. The FAA, the Federal Aviation Administration, has established 3 categories of UAS operations. There's public, which is considered governmental. There's civil, so non-governmental, private, and even some public uses are considered a civil application, commercial application. And there's model aircraft, which is the hobby or recreation only. You know, the FAA has a great website listed there on that slide that points you to all kinds of resources on UAS, and I highly recommend you look at that if you haven't already, if this is a technology you intend to adopt. But I do think it's safe to say that anyone on this call, for the intents and purposes of aerial survey, will not fall under model aircraft rules or hobby or recreation rules. You know, especially earlier on, there was a lot of hype and a lot of talk about, oh well, I own this quadcopter for recreation, and I just brought it to work because I thought it'd be useful to do a, you know, accident reconstruction for the police department, and it was cool and it was great, but that is still not a hobby use. You know, even farmers who want to go, they buy a drone and they just want to go fly their crop to observe it, and not charging anybody, no money's being exchanged, but that's a commercial use. According to the FAA, you know, we don't want to walk the line of exposing ourselves or our organizations to undue liability or harm if something were to go wrong. So, safe to say that we're all public or civil commercial users. So, a little bit, if you're a public entity, that could be federal, state, local government. Most universities will apply as well, although there are cases where you may need a commercial permit. So, but if you are operating a drone publicly, it requires a certificate of authorization or waiver. I'll go more into what that is later, but that is your permit from the FAA to operate. It may require a Class 2 medical exam. That's an FAA medical exam, the same exam that commercial pilots of manned aircraft are required to take. It just means you meet a certain set of standards that while that aircraft is in the air, you can keep it in the air and land it safely. You may require a passing grade on an FAA ground exam, which are designed and tailored towards the pilots of manned aircraft, but you may have to pass that in order to be the operator of a UAS under a public COA. You will need a letter from the Attorney General's office of your state confirming that you are a government entity. Sort of a little hoop they have you jump through, but you do have to get a certified letter saying, yes, the city of Jerome is a government entity. It has to be a public aircraft, either purchased or leased by the government agency. There can be no commercial purpose associated with it, so there are some gray areas where maybe you're a university partnering with a private company and you are doing research and development for new technology on what will ultimately be productized. That would be considered a commercial purpose, and you'll likely need a different permit, the 333 permit that we'll talk about. And pretty much all operations have been limited to 400 feet above ground level max altitude. So what is considered commercial use? If it's revenue generating, and that means whether you're charging for the data or you're charging for the flight or whatever. You know, real estate guys were out there flying it saying, oh, I just charge for the pictures, I don't charge for the flight, but that's still a commercial use. Even if you're the real estate agent and you're flying it for your listings, that's a commercial use. It doesn't have to be revenue generating. That's like the farmer example where he's using it to monitor his crops. take infrared photos regularly to assess where there are problems. You know, if he's doing that without a permit, then he is likely in violation of the FAA regulations and could be fined or imprisoned. You know, right now the FAA is threatening up to a $25,000 fine and up to 20 years in prison. That's a pretty hefty punishment, I think, but they do have more than 20 cases that are currently open, several of which have been issued fines and others which are under investigation or litigation. We don't want to get in those spots. And like I mentioned, this may apply to some government operations. So always check with the FAA if you can ever get a hold of them, or legal counsel if you're not certain whether or not your application is considered commercial. So for civil operations, it involves a Section 333 exemption, which we got. There are about 1,500 of those that have been issued now. To give you some perspective, at the first of this year, there were only about 100 of them. The FAA has established some precedent and streamlined some of their policies and rules to make that a less painful process, but it still takes at least a few months to get it approved once you've got all your ducks in a row. And that is the main process. That is the first step, I guess, in commercial operations for civil entities. Once you have your Section 333 permit, you then have to go get a COA. And I'll talk about what COA is involved, but that's per site. So 333, step 1, COA, step 2. Right now, all 333 exemptions have required a licensed pilot. This is kind of an interesting deal, and this will probably change once the official UAS operations rule comes out in a couple of years. But right now, you have to be a licensed pilot for manned aircraft, whether that be a sport, recreation, private, or commercial pilot license. You have to have a pilot license to fly a manned aircraft in order to be the pilot in command of an unmanned aircraft. So I am a licensed pilot. I have my private pilot license, which allows me to be the pilot in command of the Trimble UX5 under our Section 333 exemption. We have another guy here, Jamin Frostenson, who is also a licensed pilot. So he or I will be the ones that have to operate it. You know, that'll probably change eventually, but those are the rules right now. That is kind of a hurdle because there's a cost associated with that, and it seems a little funny that I have to know how to fly a real airplane in order to stand on the ground and fly a robot with a computer, but that's how it is. You also, each time you're going to operate or fly, you have to file a NOTAM, or a Notice to Airmen, 48 to 72 hours prior to your flight operations. A NOTAM is the same thing that gets issued like at an airport when there's going to be a runway closure or something. It notifies other air traffic that there are UAS activities in the vicinity and that they should avoid those areas at low level. And on civil operations, there's also been somewhat of a standard at a 400-foot AGL max. So what is a COA? A COA is required, as has been mentioned, for both public and private entities. The public COA, there are different web portals and different systems for public COAs and civil COAs. But the public COA is a little more involved because if they're skipping the Section 333, like they are, then they've got a little bit more information they provide. And the civil COA, we've already established kind of the ground rules with the 333, and so we just it's a fairly streamlined process. And you can get a civil COA if it's a simple site and you're not asking for anything too complicated. It'll usually come back within 1 to 3 weeks. They're shooting for 3 or 15 business days as their target time. It could be more than that, but that's their target, so it's coming around a little quicker than it used to. So it is a somewhat streamlined process. COAs are site or location specific. They are also aircraft specific and organization specific. So you've got to have, say, you know, this is a lot long of the center of the site, and I'm going to fly within a 2 nautical mile radius of this point, or something along those lines. And I'm going to be flying the Trimble UX5 and its electronic data solutions who's operating it. And those are all specific requirements for a COA. They may include special provisions, so outside of the standard rules, kind of out of the box, there may be some special rules that they issue in a COA, and that might be determined by the Air Traffic Control Center, whether it's Salt Lake or Houston or wherever you might be. They might have a different set of rules that they want unmanned aircraft to abide by in their area. So Elecdata's 333 exemption, what does it mean for you and me? There are 3 business areas that we are focusing on with UAS. The first of which being data-driven UAS services. We are also providing UAS system sales and support and training. Initially when we set out to do this, we thought we would just continue, our traditional relationship with Trimble and offer their UAS systems for sale to our customers. And we have done that, and we are doing that. But it became quite clear that Trimble's been very conservative about who they sell it to and whether or not that person is legally authorized to fly before they sell it to you. They don't want to put the customer in a situation where you might be exposing yourself to undue risk. And our customers are quickly finding that too, that hey, if we want to do this right, there's a lot of hoops we got to jump through. There's a lot of regulations to deal with, permitting. It's a lot of cost and time. There's all this extra software we need. They find that the drone's the cheap part and everything else adds up. And so what we're doing to help accommodate that is provide the service, the data-driven service. So if you, and we'll get into this, but essentially you can hire our company to come out, fly a project for you, and at the end of the day, at the end of the service agreement, what you get is data deliverables that you can act on. You can just take that information, do with it as you will. With our GIS experience and folks here, we can do a number of different levels of data analysis or interpretation, but even if you just want the standard out-of-the-box deliverables, here you go. You run with it. That lets you avoid all the regulatory stuff, the insurance, the liability, the operations, the pilot license, the medicals, all these things that a lot of people didn't think of that actually make it a lot harder to go just out and buy a system than we originally all thought. So these are the areas we're focusing on. The data-driven services will involve a process something like this. We'll start out with some mission planning, identifying what your objectives are, doing the regulatory and permitting side of things. Then there will be some on-site UAS data collection. We'll go fly the site. Back in the office, we'll process and analyze the data. Then we can just export it, or we can possibly classify, analyze, or interpret it according to your specifications, and ultimately we'll deliver to you the data in an actionable format. So a little bit about our history here. So back in March of last year, 2014, we had a fantastic and successful UX5 demonstration, one of the first of its kind, and certainly the first in Idaho. Had about 70 people come. Some of you were there, I'm sure, and some representatives from Trimble came to demonstrate the system, and it was a great day. And that was kind of our first big event surrounding UAS, and we'll continue to do things like this. We have 4 staff members who are trained and certified in UX5 operations. That'd be myself in that photo on the bottom right. You see myself on the left, Michael Clancy in the center, and Cliff Askew on the right. We were trained back in November, and it was about 10 degrees outside. In fact, when we showed up at the site, it was 3 degrees. It was pretty darn chilly, and the UX5 performed quite well despite the cold temps, and we all somehow survived and had a good experience. But we've got Jamin Frostenson has also been trained on the UX5. He's the other pilot. So we've got 4 because obviously for some redundancy and support, it's nice to have multiple people who know how to operate it, but you're also required to have a visual observer under our 333 exemption. So we've got to have 2 people out there. One's the pilot in command, monitoring the aircraft, operating the mission planning software on the computer, and then one's got to be a visual observer. His job is just to keep eyes on that plane the whole time. When you get flying around a flock of turkey buzzards, that UX5 starts looking a lot like a buzzard, and it's nice to have 2 sets of eyes at least on it to keep track of it. So we sold the first UX5 in Idaho in December. We've been an active member of the UAS working group, which meets periodically to discuss issues and things surrounding UAS. We've got the 2 certificated pilots, and the bottom line is we're ready and legal to fly commercially. So if you're interested at any point in requesting a proposal for services, it's a fairly simple process. We'd start out by just identifying the area of interest, identifying what outcome and deliverables you want, and then we would provide you with a proposal and pricing. Everything's done kind of on a case-by-case basis. We have some day rates and hourly rates we base things off of. Depending on the project, it may even be a per acre rate or something like that. But come to us with your project, and we'll identify what those costs would be and what you can get out of it. Message here is to let Elecdata focus on the UAS so that you can focus on the data. Don't get too bogged down by everything that is involved in these systems if you don't have to, if you just need to focus on the data. Let us help you. All right, we'll briefly go through the current UAS technology and then have some time for questions. As has been mentioned, there's all kinds of aircraft out there, multi-rotors, fixed wings, all many designed for surveying, many hodgepodge homemade kits that are put together. You can go build your own. You know, these range from $1,000, $500 to $100,000, and they're all over the board. So lots of options out there. So how do you kind of focus on what's needed? I mean, it's the same story with controllers and software, both mission planning and data processing. Plenty of options. I'm not here I mean, we represent the Trimble system, of course, but we recognize there are many others, and there are other good ones out there. The fact of the matter is a lot of these hardware products are quickly becoming commoditized. And so it becomes less about the drone, more about the workflow and the data. The sensors are a big piece of it, too. That one in the top center, that Sony camera, is the A5100. That's the camera that's used in the Trimble UX5. You know, we're getting a lot of these smaller, compact DSLR cameras, like this one that's 24 megapixels, takes very high resolution images. Put a custom lens on that, and you've got something really, really neat. There are a lot of others are just using a point-and-shoot digital camera. They have their limitations. The GoPros have been on a bunch of them. Obviously, that's been a popular one. Great for video, not so great for aerial survey. I've seen an aerial survey done with still images in a GoPro, and there were aberrations galore. It just was pretty terrible. So make sure you've got the right sensor for the job. You know, a lot of the other sensors coming out that are getting smaller and useful are hyperspectral, multispectral, thermal. And that one on the lower right is a LiDAR puck, a LiDAR sensor that's very small and inexpensive that can be mounted on some UAVs. And things are going that way. Sensors are getting smaller and much better. But they're not always paired or married nicely to the aircraft yet. Just remember, it's all about the data. That's what we're really after. If we focus too much on the systems and the fun of flying, then we get distracted from our real jobs in GIS and engineering, and that is to use nice data sets like this colorized point cloud for design and planning and other mission-critical decision-making uses. So bottom line, lots of available systems. Sensors are getting smaller and better. Drones are getting cheaper. But there's more to it than just the UAS, than just the drone. Remember what it's about, that data. Let me give you an overview on the Trimble portfolio before we close here. Trimble now has 3 aircraft in its UAS portfolio. The UX5 is a fully autonomous system. That's kind of the bread and butter. That's the main system we will be flying. It can achieve down to 2-centimeter resolution in your imagery. That uses the 24 megapixel Sony A5100 camera. What's unique about that compared to some of the cameras put in other off-the-shelf survey drones, UAS systems, is the Sony is a mirrorless. there are fewer moving parts in this camera than there are in other parts. And on top of that, Trimble had a custom lens made by Voigtlander, which is a fixed focal length and laser calibrated lens that gets attached to this Sony camera. So they've eliminated as many moving parts in that as possible. Why that's important for photogrammetry work is because we're putting this thing in a payload bay of a small airplane that weighs 5 pounds that's going to crash land every time. You know, you hope they're smooth belly landings, but essentially they're coming in for a skid every time. That means that camera's going to get jarred over and over and over. If you have a lot of moving parts, like some of those little point and shoots, that camera will get out of calibration, and then you might think you have 2 centimeter or 5 centimeter resolution, but maybe you've got double or triple that. Maybe it's all skewed if your camera sensor's off. The Sony cameras also have a nice big actual sensor where it registers the light. It captures more light, more sensitive. You can run the UX5 with an RGB or a near-infrared camera, and it flies in light rain and up to 35-mile-an-hour winds, which that's clipping pretty good. I've seen it fly in gusts of 27 knots, and it was holding its own because it flies at 50 miles an hour, and its aerodynamics, it goes a lot faster, and that's why we launch it off a catapult and it comes in landing on a skid. But the advantages of that are we can fly in more inclement weather, more conditions, and capture that imagery even if it's not a beautiful day. It's got a 50-minute flight time, which is also pretty impressive. We always save a few minutes in reserves, but we can cover quite a bit of space. You know, last week I did a flight where we covered about 120 acres in about less than a 25-minute flight at a very high resolution. UX5 HP is sort of an enhanced version of the UX5, mainly on the sensor. So they created a bigger payload bay so that they could use the Sony A7R camera, which is 36 megapixel. They can use that in full color or infrared as well. That's got a full 35 millimeter sensor size, which that's a big deal. There's also 3 lens options, also custom calibrated, laser calibrated fixed focal length lenses, 15 millimeter, 25 millimeter, 35 millimeter. That allows you to adjust the camera for your productivity versus precision, and gives you different options. So this A7R, I have a sister who's a professional photographer, and she raves about that. That's kind of the cream of the crop in the DSLR professional camera world. So very good sensors on board. Also flies in windy conditions and light rain. Has a shorter flight time because it has a bigger, more powerful motor, which has a greater draw on the battery. And the other big thing about it is it's PPK enabled. It's post-process kinematic. Works very much like RTK does, except instead of getting those differential corrections real time, you're post-processing back in the office with Trimble Business Center. That allows you to not always have to put in ground control. So ground control points may not be required, which I haven't talked much about that, but usually we're putting ground control targets out on the ground and surveying those in with GPS. You don't always have to do that with the HP. You can get centimeter or 2 centimeter accuracy from the air with the additional GNSS sensor that Trimble put on there. That's pretty impressive and big time savings. The other big one that was recently announced is the ZX5. This is Trimble's multi-rotor solution. It can be flown autonomous or with manual controls. You can get down to 1 centimeter resolution with the 16 megapixel Olympus camera. Has a dual axis gimbal that allows you to have quite a bit of mobility with it. Takes still photos or video, so you can have there's an option for a live video feed. So for inspections, bridge inspections, tower inspections, building inspections, oblique imagery, the multi-rotor is the way to go. And so that different solution, but it kind of completes Trimble's lineup of different sensors and airframes. Doesn't fly in quite as high as winds, which is typical for multi-rotors, about 20 miles an hour, and only a 20-minute flight time, which is also typical for multi-rotors. They're usually carrying a heavier payload, and excuse me, they've got 6 motors instead of 1, so you're consuming a lot more power Very powerful tool for both aerial survey and inspections. So the final question, do I get my own drone or do I hire a service provider? Consider these things. You know, which UAS do you need to use, and perhaps more importantly, which sensor is being used? Is it a good, legitimate, high quality, high resolution camera sensor on there to where I'm going to get accurate photogrammetry data, or is it just some off-the-shelf point and shoot that costs $100 at Walmart? You know, you don't want to use the wrong sensor for the job. Data processing software, that can range anywhere from $3 grand to 15 or 20 grand. So make sure you consider that. Do you want to purchase it? What is the service provider using? Is it a reputable software program? There's obviously the regulatory stuff, 333 or COA, that you'll need to have in place, or your service provider will. Pilot license is a consideration. Insurance and liability is often overlooked and underestimated. That can be a huge cost and a big concern. Our company is invested in aviation insurance so that we have both the airframe and the pilots covered in the event of an accident. Those airplanes are not perfect, and when we're not controlling them in the air and something goes wrong, they could very well come crashing to the ground, either into somebody's property or somebody's person. And then privacy concerns. Make sure you are operating in an area where you've addressed that. Questions to ask a service provider if you're looking for these types of services. Do they have a 333 and a licensed pilot? Are they legal to fly? Do they have a COA? Can they get one? Is everything in order? Are they insured? If something goes wrong, are you on the hook, or are they? You know, who's going to go to prison, or who's going to pay that fine if something went bad? Are they geospatial professionals? You know, a lot of these companies have sprung up from aviation companies that know a lot about airplanes, or a lot about the military, or a lot about, maybe they just know a lot about drones. It was a hobby for them. And then they find out surveying, there's an interest in surveying, and they try to do it. So they're trying to learn GIS or aerial survey on the fly. You know, a company like ours has many, many years in the geospatial industry, and we've had experience in aviation, believe it or not professionally necessarily, but the founder of our company is a pilot, was in the military for many years and operated helicopters commercially. And then myself and Jamin are pilots. We do have some experience there, but most importantly, we understand your use case, we understand what you need for the data, and we can help provide that to you as geospatial professionals. Then the other thing to ask is, who owns that data? Once it's collected, do you retain ownership of it as a customer, or does that service provider retain ownership and they license it to you, or they charge you for it? If you want it a year later, can you still go get it? At Electronic Data Solutions, we maintain a policy that you, the customer, own your data. So don't get distracted by all the hype and all the fun of these things. Remember, it's not just about the drone. That's actually the cheap part. It's not all sensors and airframes are happily married yet. We're getting there, but not everything's possible with UAS just yet. And a lot of these commercial off-the-shelf systems offer the simplest workflows and might be the best solution for you. So where should your time be spent? Do you want to navigate regulations, build a drone, and develop your own workflow, or do you want to spend your time working with the data? Final poll, and this is the end, folks. You've made it. You're here. Congratulations. How is your organization most likely to use UAS for aerial surveys? Do you intend to acquire UAS and operate it yourself, contract that out to a service provider, not sure yet, or don't even plan to use it? Okay, a few more seconds here and we'll close this poll up. Thanks for hanging in there. We covered a lot of material today. Hopefully it was useful information to you. I'm going to go ahead and close this poll. Looks like about half of you said you'll be looking at subcontracting or service providers. About 20% anticipate getting your own and operating it yourself, and about 30% are still figuring that out. So that sounds like a decent split there. Great. Well, do keep us in mind, you know, as we're doing this professionally now. We are permitted and prepared to start offering or issuing proposals. If you've got a project in mind, reach out to me. My contact information is there. I'd be happy to provide you with a proposal. If you're interested in the Trimble UX5, UX5 HP, or ZX5, let us know as well, and we'll get you information on it. We're excited about this industry and this technology. We're excited to offer something new and useful to our existing customers, and we want to be able to make you successful in this and hopefully help you save some money in acquiring this kind of data. With that, I'm looking here, and if there are any questions, I've taken up a full hour of your time, but do you have any? Oh, I want to mention the handouts first. There are some handouts you can download from this presentation. They should be on your sidebar. There's data sheets for the Trimble systems, as well as a white paper that's kind of a good overview of an application of it and costs and things like that. And then there's a PDF of this slideshow if you want to save those. So if there are any questions, go ahead and type them in the chat box, or let's see, I can. And we'll answer them here as we go. Okay, I'm seeing a couple questions. All right, so what governmental uses would be classified under the commercial use? I think we kind of covered some of that, and I can't get into all the particulars. If you might consult legal counsel if you're really on the fence, but on the UAS, on the FAA's website, they have a document that'll give you some guidance there too. That's uas.faa.gov, and essentially, if there's any kind of industry use of that information that you're collecting, whether it be for R&D or if there's a partnership, like we mentioned, with a private industry or something to develop a product that will be commercialized, that may be considered commercial use, in which case the university or the public entity could apply for a Section 333. You don't have to be a private company to apply for a 333. What kind of sensors does the UX5 support? I think we covered that now. Right now there are 2 camera sensors, RGB, full color, or near infrared. There are no LiDAR or anything yet, or thermal for the UX5 in particular. You know, I would expect that Trimble will continue to develop their UAS portfolio, particularly on the side of sensors. Don't know anything factual at this point, but we anticipate that'll be added. There are some other third-party systems that we're looking at as well that may support LiDAR or hyperspectral, multispectral. But a lot of those are not yet fully integrated and kind of an off-the-shelf product. And when you're working with a homegrown system, that introduces a whole other ball of wax as far as operations are concerned. And so we'll stay tuned, I guess, and we'll see what else comes out. What do you consider high resolution? Randy asked that. That's a good question. You know, it can be tailored to your needs, but I guess on the highest end from what the UX5 can do, it would be 2 centimeter ground sampling distance. That means each pixel in that photograph represents 2 centimeters on the ground. Usually we're surveying in ground control at centimeter accuracy or so. Sometimes you may not require that much accuracy, and so maybe you just do your ground control at sub-foot, you know, mapping grade accuracy, or maybe you don't even do ground control and you just need to see relative imagery. You don't care where it's at in the world. There are lots of uses for it, but high resolution, you end up with pretty large file sizes. These orthomosaic images could be, a couple of gigs or better. Once they're all stitched together, LRS files can easily be a couple of gigabytes. So pretty high resolution imagery data files. So what is high resolution and pixel size? Okay, I think I just answered that. Is a COA needed to fly within federal land or land that has federal easements? That's a fantastic question. Federal land is kind of tricky right now. It largely depends on the agency that manages that land. So if you are, I don't remember off the top of my head which ones are being kind of the most stringent. I want to say it's the Forest Service and the Fish and Wildlife or National Park Service. So it depends on who manages it. It could be done, but really to fly on federal lands, you need permission of the agency that manages it, whether that be for if you're flying for, or we were flying for the federal government. We would just need to work with you to get in place the proper contract. I'm sure there's a process or time frame for that before it could be before we could be contracted. Or if you are wanting to fly it, you are a federal employee, you would need to work with your agency as well. I do know that any agencies that fall under the Department of the Interior have their own subset of rules, and then the Forest Service also has a whole committee that's actively working on their own set of rules for unmanned aircraft. Unfortunately, as a federal employee, you can't just go out and start doing something on your own. I'm sure you'll run into some hiccups somewhere. The Department of the Interior is very involved in watching this and monitoring it, identifying systems that they'll approve and methods that they'll approve. But as of today, it's not something you can just go and do right away. You do need agency permission, and that's going to vary depending on who and what and all that. And with easements, Brig, that might be, it's probably the same answer. You'd need to check with the federal agency in question. What is the flight time of the UX5? I think we answered that. Up to 50 minutes, although our 333 requires we leave at least 5 minutes in reserve, which means we need to have that thing landed at 45 minutes. What percent of the $89 billion spent is for military uses? They tend to take up a bigger gulp. That's a fine point, and that's true. I couldn't tell you exactly, but I've heard that earlier in this decade that chart was showing that 2011 era, the majority of it was military, but they anticipate over that 10-year period or the coming 10 years that's going to shift, and that we'll see the civil or commercial use of UAS teeter to be the heavier user and the more revenue generating segment of the UAS industry. So military use is still a big use, always will be, but I think that will continue to change. What about hot air balloon pilots? Do they qualify as a licensed pilot? I believe the answer is yes, because I believe if you're a hot air balloon pilot, I think that falls under the lighter than air category. I have my pilot license for a single engine airplane, and it's a private category, so I think that works. I think hot air balloon, I think you have a minimum have to have a sport pilot license and be certified by someone an instructor who can certify you or pass you, an examiner who can pass you off as a hot air balloon pilot. So I believe that would qualify. The main reasoning in my interpretation as to why we even have to have a pilot license is because the FAA doesn't want a bunch of people that don't know anything about aerospace, that don't know anything about aviation, that don't know anything about how manned aircraft operate in order to properly interact with them and avoid any issues. And so usually you have some of that basic training and you're examined on those basic principles no matter what type of aircraft you're qualified for. What is the average cost for 1 square mile? That's a good question. It would probably depend on the location, the site, the terrain type. So it could depend, but I mean it probably could range anywhere from having us do it as a service, I assume, is what's being asked. could be around a couple $1,000. It could be more or less. If travel expenses are involved as well, that could play into it. But get me a KML or a shapefile or something of your site, and we'll take a look. Do you have a video of one flying? I do. I have lots of videos. Why don't I send that out in an email to the attendees? I'll send you some links. Can you attach LiDAR on the UX5? I think we answered that. Can you work in Utah? Most certainly. We are not restricted to any certain state by our 333. We just need to apply for a COA for each location. So we need to identify your site and go from there. But we can operate anywhere in the United States. How much does Elecdata charge for the UX5 and ZX5 systems? They range in price depending on the configuration, but the UX5 and ZX5 systems are full solution systems. So when you buy them, you get not just the aircraft, but you're getting the launcher, you're getting a ground control station, which means a tablet computer, rugged, the Trimble Access, the mission planning software, and usually you're getting the office software as well. And they can range between $20,000 and $50,000. Depends on the configuration. And then there's usually some training, maybe some spare parts and things like that you'll add in there too. You know, I've seen them priced out between $30,000 and $100,000. Can the photogrammetry software be used with ground-based photos? Yes. Many of the photogrammetry software programs can be used with ground-based photos. There are certain principles you got to follow. Trimble Business Center supports oblique photogrammetry from the Trimble V10, which is a ground-based imaging rover system, which is pretty cool. It does do that. Trimble Business Center does a whole lot of things. There are other softwares that are more focused, like Trimble UAS Master is actually another photogrammetry software program that just does that. There's others out there like Pix4D, Agisoft's system, and those are kind of a couple of the more popular ones. There's a whole bunch of them out there, though. Can the photogrammetry software, oh, I think we answered that. Do you have a standard price sheet, estimated cost, so we can have a baseline price? At this time, we do not. We're still learning and how to estimate these projects and make sure we cover our costs and the cost of our equipment and people and training and everything else. So we don't have a fixed cost sheet right now. That may be available in the future, but as of now, it's on a case-by-case basis, so we encourage you to reach out to us. We're primarily basing things on time and materials. How long is it going to take us to do the job? And what materials, if any, do we have to acquire to get the job done? So let us know, but I mean, projects I could see ranging from anywhere from $1,000 to tens of thousands of dollars, depending on what you're after. Is it possible to create a 3D image of the seafloor? Maybe. That might involve some different sensors. I'd say today we are not equipped to do that, but that could be down the road. What was your turnaround for the 120 acres, 25-minute flight, and what data products did you produce? So the turnaround time, I actually just finished processing the data yesterday. So I guess it was a week, but it wasn't chewing on it all week. And I was using my laptop as opposed to a better equipped workstation for that kind of process. So, it'd take me about a half hour to get the project going. Then I had to chew on it to do the orthomosaic, which can take several hours or a few hours. Then you do a ground control adjustment, which can take another half hour, an hour, and then we ran it through the orthomosaic and the data outputs. I output a LAS file, a digital surface model, and an orthomosaic, a geotiff. And I think to produce all those, it was running most of the day yesterday, probably about 8 hours. That's just my computer crunching. That's not me actively doing things. But with a better computer, those 8-hour periods can be cut down into 2. So our goal is to eventually get it to where we can turn around data in 24 to 48 hours to the customer. Probably won't be that right away, but we'll get there. Can you tie the surface to Idaho survey control points? You certainly could. If there's existing control, you could use it. You would need to be able to see that point in the images, though. That's the key. So if you know there's a monument or a benchmark, you could take an aerial target, lay it on top of that, and then pull the coordinates from that benchmark when you do your ground control and the post-processing. So yeah, you could certainly use existing control, including Idaho survey control, but you would just need to prepare for it properly and make sure it's marked or targeted so that you'll see it in the photos. What is typical data size of all images acquired during a high-resolution flight, and what are suggestions to improve upload speeds? Typical data size of all images. So, you know, in this recent one that is fresh in my head, about each photo was about 8 or 9 megabytes, each individual photograph, and there were 620 photographs for a 120-acre area. And you know, then when I did the LAS file, the LAS file was about 1.5 gigs. I couldn't tell you, didn't look at what the mosaic was, but probably around 1 gig. So they come out pretty big. You end up, and as you do more and more of these, and if you're doing a large site, then you would end up with several gigabytes, and eventually we'll end up with terabytes of data that we'll be managing. And we'll be delivering those to you in the most efficient way we can find. Yeah, suggestions to improve upload speeds. Come back to me in a couple of months with that, and we'll see what I've come up with. One is a solid-state drive, better processors. The processor has more to do with it than the RAM, as I understand it, on the data processing side of things. So we're evaluating things and trying to sort out some of those things ourselves. I assume Trimble is processing the images in the cloud. Is this correct? That is not correct. Trimble is not doing any image processing in the cloud. It's all done on the desktop. I've been doing it with Trimble Business Center or UAS Master. And there are other programs out there that can do it as well. All right, that's all the questions I had show up. Thank you very much all for your patience and for attending today. We covered a lot of ground, and we look forward to working with you on UAS, whether you look to operate your own system or you need a service provider. Do keep in touch with us and let us know what we can do. We'll send out a survey, and feel free to respond to that with any inquiries you might have, and we look forward to working with you. We'll end this call now. Have a great day.